Without pollinators, our world would look very different. They're not just cute or interesting, they're vital. Up to 95% of flowering plants depend on these creatures for reproduction. And that's not just about the beauty in your garden, it's about the food on your table and the oxygen you breathe. The economic value of pollinators transcends mere figures, but it is quantifiable nonetheless. An astonishing $217 billion is injected into the global economy annually through their pollination services alone. In addition to their global economic impact, pollinators play a crucial role in supporting local communities. Small-scale farmers and beekeepers rely on pollinators to enhance crop yields and sustain livelihoods. Moreover, ecotourism ventures centered around pollinator habitats contribute to local economies, attracting visitors eager to witness the beauty of pollinator-dependent ecosystems. Among pollinators, honeybees emerge as agricultural powerhouses, driving significant economic gains. In the United States, honeybees contribute substantially to agricultural productivity, with their pollination services accounting for between $1.2 and $5.4 billion. While honeybees have long been hailed as the poster child of pollination, recent research has cast a spotlight on the comparative effectiveness of various pollinators. Contrary to conventional wisdom, studies reveal that honeybees do not always reign supreme in the realm of pollination. Honeybees are undeniably prolific visitors to flowers, but their effectiveness as pollinators varies depending on the context. In some cases, honeybees may indeed excel as pollinators, efficiently transferring pollen between flowers and contributing to high rates of fertilization. However, in other scenarios, honeybees may fall short in terms of effectiveness, failing to adequately deposit pollen on receptive stigmas, or navigating challenges posed by complex floral structures. In fact, when compared to other pollinator groups, honeybees often do not emerge as the most effective pollinators. The pollination landscape is rich and diverse, populated by a plethora of pollinator species ranging from bees and butterflies to birds and bats. Each species brings its own unique set of traits and behaviors to the table, influencing its effectiveness as a pollinator. For example, buzz-pollinated plants, such as tomatoes and blueberries, rely on vibrations generated by bees, including honeybees, to release pollen from their anthers. In contrast, plants with specialized floral structures may be better suited to other pollinator species with different foraging behaviors. Bumblebees, honeybees, and solitary bees collectively account for a significant portion of plant pollination. Studies indicate that bees contribute to the pollination of approximately 80% of flowering plant species worldwide. Their efficiency in transferring pollen between flowers makes them indispensable contributors to both natural ecosystems and agricultural landscapes. Hoverflies, although often overlooked, play an important role in pollination as well. With their remarkable agility and widespread distribution, hoverflies visit a vast array of flowering plants, including many food crops and wildflowers. Research suggests that hoverflies contribute to the pollination of over 70% of global food crops and more than 70% of animal-pollinated wildflowers. Despite their smaller size compared to bees, hoverflies make a significant impact on plant reproduction through their frequent visits to flowers. In addition to bees and hoverflies, other insect species also contribute to pollination to varying degrees. Butterflies, moths, beetles, and even ants play roles in pollination, although their contributions may be more limited compared to bees and hoverflies. While not as efficient as other pollinators, beetles contribute to the pollination of a variety of plant species, particularly those with the large, bowl-shaped flowers that are well suited for beetle visitation. Wasps do visit flowers for nectar, and in the process they can pollinate. They're more known for predation, but their role in pollination shouldn't be underestimated. Ants can become pollinators too in areas where other pollinators are scarce. However, Their effectiveness can be limited due to their tendency to consume pollen rather than just transfer it. Birds, particularly hummingbirds and certain species of passerines, also serve as pollinators for a wide range of plant species. With their long, slender bills and specialized feeding behaviors, hummingbirds are especially adept at extracting nectar from tubular flowers. Research suggests that birds contribute to the pollination of approximately 5 to 10% of flowering plant species, particularly in regions with abundant bird diversity, such as tropical rainforests. Although less common than insect and avian pollinators, certain mammals also play a role in pollination. Bats, in particular, are important pollinators for many night-blooming plant species, including agaves and cacti. Their nocturnal foraging habits and long tongues make them efficient pollinators for flowers that are adapted to bat pollination. Research indicates that bats contribute to the pollination of approximately 500 plant species worldwide. In certain environments, rodents like mice and squirrels can also contribute to pollination. For example, in the high Andes, the long-whiskered mouse pollinates the flowers of the pia plant, which has evolved to attract these rodents. Some species of cactus in the Sonoran Desert are pollinated by small rodents, where the flowers are large and sturdy enough to support their weight while they feed on nectar. So, next time you see a bee, a butterfly, or even a bat, remember, they're not just passing through, they're working hard to keep our world vibrant and alive. And that's why we need to keep their habitat safe, reduce pesticide use, and promote biodiversity.